Perfect. Awesome. All right. Thank you very much. And good afternoon, evening, morning, maybe to some of the folks online. My name is Nicholas Boucher, and I'm here to talk about a topic I'm grouping under the title Invisible Hacks. So let's try and grab you with that catchy title. So the idea here is that we want to find a way to use atypical text encodings to break systems that are developed, they're deployed at scale in the world right now. And there's a couple of specific systems in mind. Let's first talk about the broad idea of programming languages and what it means to attack a programming language. So let me introduce a specific vulnerability. So in this vulnerability, imagine first that we have control characters and that these control characters have the ability to override the direction that text flows on a particular page or screen. Imagine, for example, that we have English, which might flow left to right, and maybe we have Hebrew or Arabic, which might flow right to left. So these control characters can modify the display order of existing text. But we also know that these control characters can be placed into comments and strings within source code. So think about that. It means that I can take some special character and I can put it inside of a comment or a string in my program's source code, and I can use it to affect the display order of characters that are outside of that comment or string. So the result from this is that I can take some evil program, we'll call it A, and I can anagram it by shuffling around the letters into some benign program B. So let's look at an example of this. So imagine that I have some C program that is pretty straightforward. I'm setting a variable to false, saying that I'm not an admin, and then I've got something weird going on, but I'm checking to see if I'm an admin, tell me that I'm an admin. So let's take a closer look at this line here, which might look a little bit strange, but again, it should have nothing happen. This should be a no-op based on the specific code. So what the compiler sees is actually a big long comment like this. What the human sees is this, because we're using control characters that are not going to render in this particular visualization, but will cause the text to flow differently. I'm taking some comment that's big and long, and I'm making it look like it's smaller than it actually is. So as a human, someone who's reviewing this code, I think that something is code that's being executed, when in fact it is not actually code that's being executed. It's simply just a big long comment. And there are, it turns out, dozens of different ways that you can use this same sort of trick to hide code in plain sight, or to make things that don't look like code execute in some way. But the result here is that if I run this program, what do you know? Despite the fact that a code reviewer will say, surely I will not be an admin, I am in fact an admin when I run this code. So we call this the Trojan source attack. We had a paper that came out on it last year. But that's not the only strange thing that you can do with these weird text encodings. Let's also talk about machine learning. It's now 2023. Every talk has to have a machine learning component. So let's go ahead and put this in here. So this same trick can be used to confuse machine learning inference pipelines. And what do I mean by that? I mean that me as a user, I put something into a model. It looks like whatever it renders on my screen, but the model is going to see something different than myself. I'm going to see the rendered version. The model is going to see the encoded version. And if I'm using some of these strange tricks, it might mean that the model sees something very different than what I actually see. So let's go back to this example from just a moment ago, where we were using these control characters that allow us to reorder tokens, reorder text that's being displayed on a screen. So imagine I have a machine learning model that does toxic content classification. The idea is maybe I want to screen out things that are nasty language that's being used somewhere online. But to try and evade this model, what I do is I shuffle around my characters, but then I use these reordering control characters to unshuffle them when they're displayed, so that the human sees, whatever we expect them to see in English or whatever language we're using, but the model is going to see a shuffled version of that. The result, it sees these shuffled characters that make no sense. It says, oh, that must not be toxic. It doesn't flag as something that I know to be toxic based on what I'm trained on. Similarly, there are other techniques that we can use. For example, there are characters that are defined in, say, the Unicode specification, which is pretty much the only thing that's used in modern computing for text. These are characters, we call them invisible characters, that are designed to render to the absence of a glyph, such as the zero width space. Turns out, if you want to be really simple, you can take these invisible characters and just inject them into some string, and most models will begin to behave entirely differently than what you would expect in the absence of these characters that the human can't see. Very similarly, there's characters that look very similar, but are represented by different encoded representations, different code points under the hood. We call these homoglyphs, such as characters that look the same in Cyrillic and Latin, and you can shuffle these arbitrarily. Spammers have known this for a long time in email and in online forums. Turns out it works broadly across the natural language processing space. And then lastly, I have these ideas of deletions, which, when you hit the backspace character on your computer, there is a control character that represents that. It turns out you can inject these into strings and it will remove the thing that precedes those deletion characters. So me as a user, I don't see these things, but the encoded representation of the text, well, anything that's looking at that, like an NLP model, will see that. So finally, I want to talk a little bit about coordinated disclosure and what it means when you find some set of vulnerabilities that broadly affects different pieces of software, or maybe kind of a whole section of the industry. And I'll just call out, for the sake of time, that there were a whole bunch of different pieces of software. I'll put 6 of them up on the screen here, that were patched to defend against the source code version of this attack, this Trojan source attack that we talked about a minute ago. I'll also put out there, though, that while we actually released the NLP version of this almost a year earlier than we released the source code version of this, most NLP systems remain unpatched against this based off of latest testing against large language models that are currently deployed. So kind of an interesting dichotomy to draw there between what vulnerability patching and coordinated disclosure looks like in this growing world of machine learning, and what it looks like within the traditional world of software engineering and more traditional programming languages. So if you'd like to learn more about these, I'll put links up here to 2 different websites we've got. They give an overview of these attacks, and including some little generators you can use to come up with examples against your own systems. So thank you very much.